Hey guys, in this video I'm going to be running through all the solutions for the Edexcel Paper 2 A-Level for 2024. Every question is going to be timestamped so you can easily jump to a question or rewatch it if you need to. Hope this helps. Okay, so here we are at the front of the paper. Question 1 says, find in the simplest form the derivative of this equation, so just using the power rule to differentiate, we'd get dy by dx is equal to 12x squared minus 14x plus 5. That's A part 1. Then part 2, we need the second derivative, so just differentiating again using the power rule. So that would be 24x minus 14. Then for part B, it says, hence find the exact value of x when the second derivative is equal to 0. So we can just set the second derivative equal to 0. 24x minus 14 equals 0. That's going to give us x equals 14 over 24, which is the same as 7 over 12. Moving on to question 2. It says Jamie takes out an interest-free loan of £8,100. Jamie makes a payment every month to pay back the loan. Jamie repays £400 in month 1, 390 in month 2, and 380 in month 3, and so on. So the amounts repaid each month form an arithmetic series. Show that Jamie repays £290 in month 12. So just looking at that, we know the common difference of our arithmetic series is minus 10. So then thinking about the 12th month, well, the nth term formula is a plus n minus 1d. And our first term is £400. So we're looking for U12, which would be 400 plus 12 minus 1, that's 11, times our difference of minus 10. Plugging that in the calculator, that's 400, it'll be minus 11 times 10. That gives us £290, which is what they asked us to confirm. Then it says, after Jamie's nth payment, the loan is completely paid back. Show that n squared minus 81n plus 1620 equals 0. Well, that means in total he must have paid his full amount of the loan, and that's going to be the sum of all his payments. So the Sn formula, the sum of n terms formula, is n over 2, 2a plus n minus 1d. So utilizing that, trying to find n, it would be 2 lots of 400, that's 800, plus n minus 1 times minus 10, and all of that must equal 8,100. So I think I'll multiply both sides by 2, as well as simplify this bracket. So the half would disappear on the left, and inside the bracket, what would we get? We would get 800 plus a 10 because of the double minus, so 810. And then we'd get a minus 10n equals 8,100. Oh, sorry, not 8,100. We've got to double it now. What would that be? That'd be 16,200. Then expanding the bracket, we would have minus 10 n squared plus 810n equals 16,200. And then we can cancel off a factor of 10 from everything, so that 10 goes there. We'll lose a 0 on each of these guys. And if I bring it all over to the right-hand side to make my n squared positive, we're going to be left with the result we wanted. Okay, then it says just hence find the value of n. So I think, honestly, I would just use my quadratic formula solver and my calculator when the coefficients are that big. So if we go to home, then equation, polynomial, quadratic, type in our coefficients, that's 1, minus 81, and 1620. That would give you 45 or 36. And then we need to think which of those makes sense. Sorry, not plus 36 or 36. Well, if we think about it, at some point, he's going to accrue more and more interest. But if there's £10 coming off, this sequence is kind of predicting that it's going to go, his repayments will become negative, and that's why it would come back down again to £8,100. So it's going to be the smallest value of n, the first time it reaches that value. So the actual value is n equals 36, and we'll just cross that out to make sure. Moving on to question 3. It says the point P lies on the curve y equals f of x, where x is any real number. Find the coordinates of the point to which P is mapped when the curve with equation y equals f of x is transformed to the curve with equation, and then there's 3 separate graph transformations. Okay, so for part 1, that's straightforward. That's just going to translate the x coordinates. So 3 minus 2, we're just going to add 2 to the x coordinates. So that's going to become 5 minus 2. Then part 2, the 2x, that's just going to half all our x coordinates. So it's going to go to 3 over 2 minus 2. And then the last part, there's multiple. So we have to watch out for the order, potentially. So I'll always just use the correct order just in case it does matter. So for us, that's going to be multiplying the x coordinates by -1 first. So we'll start with 3 minus 2. Then it would become, well, division if you really want to think about it, but dividing and multiplying by -1 is the same thing. So -3 minus 2. Then multiplying the y coordinate by 3. So that would become -3 minus 6. And then adding 5 to the y coordinate. So the final answer would be -3 minus 1. Moving on to question 4. There's a sequence u1, u2, u3 is defined by this recurrence relation, where k is a positive constant. Given that u3 equals -1, show that k satisfies this quadratic. So first, let's use the recurrence relation to get a form for the u3, and then we can use this piece of information here. So if u1 is 6, that would make u2 6k minus 5. And then u3 would be k times 6k minus 5 minus another 5. But we know that's actually equal to -1 from the information. Then multiplying out the bracket, we'd have 6k squared minus 5k. Then we've got a -5, we're going to add the 1 over, which makes it -4 equals 0, and then we've got the result they asked for. Then they've given us, then they say hence find the value of k. So we need to solve this quadratic, but reminding ourselves that it's a positive constant, so we only want a positive solution. So let's see, I think this is factorizable. I think it's going to be 3k and 2k. And then if we put a -4 here, that gives us -8k, and then a +1 here, that would give us a -4, -8, and then plus a 3, which would give us the -5. So then k is going to be equal to 4 over 3, 4 minus a half, but remembering what we said earlier, we can't take the negative solution, so k is just going to be 4 over 3. Then part 2 just says, can we sum the first 3 terms of this series? So that's easy now that we've got k, or u1 is 6, u2, using what we did earlier, would be 6 times 4 over 3, oops, minus 5. Let's plug that in the calculator. 6 times 4 over 3 minus 5. That gives us 3. Then u3 would be 4 over 3 times 3 times 3 minus 5. 4 over 3 times 3 gives us a 4, and then minus 5, that gives us minus 1. So our sum of the first 3 terms is going to be 6 plus 3 minus 1. That's 9 minus 1, which is 8. Moving on to question 5. It says, given that theta is small and in radians, use the small angle approximation to find an approximate numerical value of theta tan 2 theta all over 1 minus cos 3 theta. So we're going to need the tan and cos small angle approximation, so let's just write them out. So tan x is approximately equal to x, and cos of x is approximately equal to 1 minus x squared over 2. But what we have to watch out for is the angles in ours have changed, so we have to just insert those appropriately into each approximation when we use that. So theta over tan 2 theta over 1 minus cos 3 theta is going to be equal to, approximately equal to, theta times 2 theta, using the tan approximation, and then 1 minus, and I'll use a bracket here, another 1 minus, it's going to be 3 theta all squared over 2. Now let's start to simplify that. So on the top we'd have 2 theta squared. On the bottom those 1's are going to cancel. And then we're going to have a 9 theta squared all over 2. The theta squareds are going to cancel. And let's multiply the top and bottom by a 2 to simplify the fraction. I'm allowed to do that because that's just multiplying by 1, which doesn't change the value. So then we'd have 4/9 as the final answer. Moving on to question 6. It says figure 1 shows a sketch of the curves y equals f of x and y equals g of x, both with domains of x greater than 0. Part A says, can we first find the derivatives of each function? So, A part 1, well, our function of x was e to the 4x squared minus 1. Oops. E to the 4x squared minus 1. Oops. E to the power of 4x squared minus 1. There we go. Then we have to differentiate that. So we've got a function composed with another function. So first we need the chain rule, and first we differentiate the inside. So 4x squared minus 1, that just gives us an 8x. F dash of x is going to be 8x. Then differentiating the exponential, that doesn't change. So it would just be 8x times e to the 4x squared minus 1. Then for part 2, g of x is 8 ln x, which is just a straightforward derivative. The derivative of ln x is 1 over x, meaning g dash of x will be 8 all divided by x. Next, it says, given that f dash of x equals g dash of x at x equals alpha, show that alpha satisfies this equation. Okay, so if it's satisfying that equation, we can just actually set it up by doing this. So equating our derivatives from before, that would give us be 8x e to the 4x squared minus 1 equals 8 over x. And then we're going to need to get rid of this exponential here. So what I think I'll do is we'll rearrange for the exponential and then log everything just to deal with that issue. But first let's divide everything by 8. Those 8s disappear. Then we'd have, well, let's take our time, x e to the 4x squared minus 1 equals, then it would be 1 over, sorry, do that on the next line, just 1 over x. Then dividing by the x, we'd have e to the 4x squared minus 1 equals 1 over x squared. Taking the natural, or using the natural log property, we then know that 4x squared minus 1 equals the natural log of 1 over x squared. And if we think about it, the natural log of 1 over x squared is the same as the natural log of x to the minus 2. So we can bring that minus 2 down as a power using our logarithm rules. So 4x squared minus 1 would be equal to minus 2 natural log of x squared. And then they had all their expression equal to 0, or their equation equal to 0. So let's bring it all to the left-hand side. Then we'd have 4x squared plus 2 ln of x squared. Sorry, that shouldn't be an x squared. That should just be an x. We brought the power down. 2 ln of x. And it should be a minus 2 ln of x, sorry. Sorry, plus 2 ln of x. And then minus 1 equals 0. Sorry about that. Okay, let's just check that's right. Yes. Good. Right, then it says the iterative formula xn plus 1 is the square root of 1 minus 2 ln xn over 4. Is used with x1 equals 0.6. Find an approximate value for alpha. To find an approximate value for alpha. Calculate giving each answer to 4 decimal places. So for the first one, just saying, can we iterate once? And for part 2, we actually need to find alpha to 4 decimal places. So what I'm going to do is set this up in my calculator. So first I'll type in the first iteration point, so that's 0.6. Then we hit equals. Now that's stored as the answer in my calculator, so I can just do the square root and type in my formula. So 1 minus 2 natural log, and then where the xn is, I'll place an answer. It's going to keep inputting my next iteration back through the formula if I want it to. Over 4, and then we'll hit execute once just to get the first iteration. So for C part 1, and this was to 4 decimal places, I think. Yeah, 4 decimal places. So to 4 decimal places, the first iteration is 0.7109. Then we're going to need to keep iterating until it doesn't change at the 4 decimal place rounding. So it still looks like it's changing. Still changing. Now it looks like it's starting to settle into, yeah. So we can see it's not changing at the 4th or 5th decimal place anymore. And it's going to round to 0.6706. That's our value for alpha. They did say alpha, didn't they? Yes. 0.6706. And both of those are to 4 dp. Moving on to question 7. Says figure 2 shows a sketch of the straight line L. Line L passes through the points A and B, and we're given the position vectors of both of them. It says, can we find AB? That's just a standard question. So AB is going to be the position vector of B minus the position vector of A. So that's going to be 5, 6, 8 minus 2 minus 3, 5. 5 minus 2 is 3. 6 double minus 3 is a 9. And 8 minus 5 is another 3. Then it says for part B, given that a point P lies on L such that A to P equals the length of A to P equals 2 lots of the length of B to P, find the possible position vectors. So there's going to be two possible answers. Well, first off, if A to P is twice the length of B to P, we know it needs to be closer to P. And one really simple way to get a point for P is if we just split the distance from A to P in a ratio of 2 to 1, then we know that if this is 2/3 of A to B, and this would be 1/3 of A to B, we know it's twice as far from A as from B. So we can find our first solution. Let's call it solution 1. Is we can think it's this point, the position vector of P is, well, first we'll go to A, that's O to A, and we'll go 2/3 of the way to B from A, so 2/3 of A to B. So that is 2 minus 3, 5, plus 2/3 of 393. Simplifying that, so that would be, well, 2/3 of 3 is 2, so it would be 2 plus 2, that's 4. 2/3 of 9 is 6, minus 3 plus 6 is a 3. 2/3 of 3 is another 2, 5 plus 2 is 7. That's one solution, 4, 3, 7. Now, a second solution is if we just went the other side of B, but by the same distance. So if we put P here, then we get the same thing, because we've got one lot of B to P here. If that's A to B, then it's 2 lots of A to B to get from A to P. So that also satisfies our equation. So doing that, we could say, well, O to P is also for solution 2. O to P, we first go to A again, so that's O to A, but this time we add on 2 lots of A to B. So writing that out, that's 2 minus 3, 5, plus 2 lots of A to B, or 393. So that's 2 plus 6, that's an 8, minus 3 plus an 18, that's 15, and 5 plus 6, that's 11. And those would be the two solutions. Moving on to question 8. We've got a trig identity to prove. So we need to show that the left-hand side equals the right-hand side. So the first thing I'll do is, on the left-hand side, we've got two fractions, or two terms. And on the right-hand side, it's all one term, because those things are multiplied together. So a good idea would just be to combine the fractions, actually make it all one term. So doing that, if we cross-multiply, we would get cosec theta, this is part A, cosec theta plus 1 plus cosec theta minus 1. And then on the bottom, we're actually going to be multiplying the difference of two squares in a kind of way. So it would be cosec squared theta and then minus 1, because the cross terms will cancel out because of the alternating signs. So simplifying that up a little bit, on the top we get 2 cosec theta over cosec squared theta minus 1. I think it would be better to turn that into a single term denominator, and we should be thinking there's a trig identity immediately there. So because if we start from cos squared theta plus sine squared theta equals 1, divide everything by sine squared theta, we get cot squared theta. Plus 1 equals cosec squared theta. Cosec squared theta. And then, so if we rearrange that, cosec squared theta minus 1 is just cot squared theta. So this becomes then 2 cosec theta over cot squared. And actually we've got, well, so 1 over cot squared, and we want 1 factor of tan. So we could write that, and let's keep the 2 as well. That's the same then as 2 tan theta, just bring like double reciprocal, is just same as bringing it up to the top if we think about it. And then we'd be left with a cosec theta over cot theta, which needs to become a sec theta, but let's take our time to demonstrate that that's definitely true. So 2 tan theta times, well, cosec theta is 1 over sine theta, and cot theta is cos theta over sine theta. Well, if we multiply the top and bottom of this by sine theta, which we're allowed to do again because that's 1, doesn't change the value of the fraction, that would cancel with those guys. Then we're left with 2 tan theta times 1 over cos theta, which is what we wanted, is the sec theta. Then it says, hence solve the equation where this is equal to cot 2x sec 2x. Well, first off, what's the difference? Like, how can we use our previous part? Well, this is the same as this, except a theta has become a 2x. So we can replace theta with 2x and completely rewrite the left-hand side. So that would be 2 tan 2x sec 2x, just using our left-hand side here. So that's all this, that's our left-hand side, and then they're saying that's equal to cot 2x sec 2x. Okay, and then at this stage you might be tempted to cancel the sec 2x's, but we don't want to do that. We could potentially lose some solutions. So if you have factors, what you always want to do is bring it to one side and then factorize it out, because factors will give us roots, provided the equation's set to 0. So we have tan 2x sec 2x minus cot 2x sec 2x equals 0. Let's factorize out the sec 2x. Then we'd have 2 tan 2x minus cot 2x equals 0, which gives us two possible solutions. First one is sec 2x equals 0. Well, sec is 1 over cos 2x. So to get a solution, we would do 1 over cos 2x, which would mean doing 1 divided by 0. So actually that isn't going to give us any solutions, as it turns out. Then the second factor, we have tan 2x minus cot 2x equals 0. This is just 1 over tan 2x, so let's multiply everything by tan 2x. That would give us 2 tan squared 2x minus 1. Then if we rearrange that, we'd get tan squared x equals a half. Sorry, tan squared 2x equals a half. So tan 2x is going to be plus or minus 1 over root 2. And then what's the range of solutions we want? Everything from 0 to 90 degrees. So we're not going to need to find many solutions. So let's find our first solution using our calculator. What it's in degrees, isn't it? Yes. So change my calculator to degrees. degrees. And then we'll do inverse tan to get our first solution. So inverse tan of, let's do the positive one first. So 1 over root 2. So for the positive 1 over root 2, we're going to get 2x equals 35.26. What do they want the rounding for? To 1 decimal place. So let's call it 35.3 actually. 35.3 degrees. And then, oh, actually, sorry, let's keep it unrounded because I haven't divided yet. 26 ... then divided by 2 in my calculator. That's going to be 17.6 to 1 decimal place. And then just thinking if there's going to be any more solutions we need to worry about from that. So the regular tan graph repeats every 180. So this graph transformation, the 2x would halve that to repeating every 90. So but still I can't actually add or subtract 90 without going out of this region. So that's the only solution I can get from the first one. Then let's do the minus 1 over root 2 now. So that one, if I put it in the calculator, let's scroll up and just make this a minus. That gives us minus 35.26. That makes sense. It's just it's an anti-symmetric graph, isn't it? It's just the same but negative. So minus 35.26. And then halving that. So that gives us minus 17.6. But that's not actually a solution in our interval. But then we remember what I said, we can add and subtract 90 from the tan 2x graph and still get another solution. So if we add 90 once, that's going to bring us into the range we're looking for. So the solution we actually want is 72.4 to 1 decimal place. And then I'll just cross this guy out so we know we don't want to include him. And that's it. Moving on to question 9. It says, figure 3 shows the path of a small ball. The ball travels in the vertical plane above horizontal ground. Ball is thrown from point A and caught at the point represented by B. The height h meters of the ball above the ground has been plotted against the horizontal distance x. Measured x meters measured from the point where the ball was thrown. Oh, that's interesting. Height 8 meters of the height h meters of the ball above the ground has been plotted against the horizontal distance x meters measured from. Oh, x is measured from where the. Okay, yeah, so it's still measured from the origin, really. With respect to a fixed origin O, the point A has coordinate 0, 2, and B 20 and then 0.8. It says the ball reaches its maximum height at x equals 9. Let's mark that on. That's coordinate 9, and we don't know the h. Find h in terms of x. So actually, because we've been given that x coordinate, that's useful to get the form, because we can think about the completed square form. We know then that, well, any quadratic can be written in this form. And if the highest point is at 9, or occurs at 9, that means our b must be equal to 9. But then we've got two unknowns, but we have two pieces of information. We have points A and points B to plug in to find our A and our C, sorry. So let's plug in the 0. So 0, 2, that gives us 2 equals A times minus 9 squared plus C. Or in other words, 81A plus C equals 2. Then plugging in the second point, that's 20 and 0.8. So we'd have 0.8 equals A times 20 minus 9, that's 11. A times 11 squared plus C. Simplifying that, we'd have 0.8, so let's write it the other way around actually. We'd have 121A plus C equals 0.8. And then let's copy this equation over from before. Oops. So there's our equation from before. I think let's subtract the bottom equation from the top equation. So if this is equation 1 and this is equation 2, let's do 1 minus 2. 81 minus 121, that would be 40 lots of A. Then the C's will cancel, and then we have 0.8 minus 2, that's minus 1.2. And then we'd have A is minus 1.2 over 40. I'll just put that in the calculator quickly. That's minus 3 over 100. Which is the same as minus 0.03. Then if we plug that back in to get C, well, C, if we go to equation 2, C would be 2 minus 81A. So let's plug that in. So that'd be 2 minus 81 times our answer we just got a second ago. That's 4.43. Or if we want it exact, 443 over 100. How did they want the form? It didn't say, so either is fine. Let's just write the full form out though. So that's y equals minus 0.03 x minus 9 squared plus 443 over 100. That's part A done. Just give one limitation of the model. So we could maybe use what we normally would do, where we haven't, like in this model, it's traveling in a vertical plane, but maybe there could be some wind going into or out of the page, so it wouldn't actually travel in a vertical plane. It would be like more of a three-dimensional motion. Does it say account for that at all? So yeah, I'll go with that. So this is part B. If there is wind, ball may not travel in a vertical plane. Okay, then it says Chandra is standing directly under the path of the ball at a point 16 meters horizontally from O, so this is x equals 16 here. Chandra can catch the ball if the ball is less than 2.5 meters off the ground. So it's basically saying this distance, h, must be less than 2.5. All we need to do then is just plug in 16 and see what our model tells us to see if Chandra can catch the ball. So C, when x equals 16, our model, sorry, before this shouldn't have been a y, should it? This was an h, really. Let's put it back as an h. So h would be minus 0.03 times 16 minus 9 all squared plus our 4.43. Plugging that in the calculator. Minus 0.03 open bracket 16 minus 9 close bracket squared plus 4.43. That gives us 74 over 25. And then what's that as a decimal? That's 2.96. Which is That's bigger than 2.5, so therefore cannot catch the ball. Okay, moving on to question 10. It says figure 4 shows a sketch of the curve C with parametric equations given there. The point P with coordinates 4, 2 lies on C. Using parametric differentiation, show that the tangent to C at P has the following equation. Okay, so parametric differentiation, so we need to use the chain rule if we want to differentiate with respect to T. So let's just write that out first. So dy by dx is going to be dy by dt times dt by dx. So then finding those derivatives we need, first let's start with the y. So y is 1 minus t cubed. So dy by dt is going to be minus 3t squared. X is t plus 3 squared. We're going to need to use the chain rule for that to differentiate that again. So differentiate the inside, t plus 3 just differentiates to 1, so it actually doesn't matter. So then dx by dt is going to be 1, I won't write, times bringing the power down 2 lots of t plus 3, leaving a power of 1, but I won't write that again. So writing out our derivative then, dy by dt is going to be, dy by dx, excuse me, is going to be dy by dt, which is minus 3t squared. And then dt by dx is just 1 over dx by dt. So that's all going to be over 2 lots of t plus 3. Then we're going to need to find the value of t for our point. So I'm going to use the x-coordinate. If x is 4, then that would mean t plus 3 squared equals 4. So that would give us t equals minus 3 plus or minus 2 solving, but it can't be minus 5 because it says t is between minus 2 and 1. So it's going to have to be minus 3 plus the 2, so t equals minus 1. Plugging that in, that would give us a tangent gradient. So we'd have minus 3 times minus 1 squared over 2 lots of minus 1 plus 3. That's just a 2. So on the numerator, we would have minus 3 times 1, because the minus 1 is squared, so just minus 3. So we minus 3 over 4. So carrying this over, we have a tangent gradient of minus 3 over 4. And we had our point P, which had coordinates of 4, 2. So using our y minus y1, so y1 is 2 times equals the gradient, the gradient is minus 3/4, x minus x1, which is x minus 4. Then let's multiply everything by 4. So that gives us 4y minus 8 equals minus 3 times x minus 4. That gives us 4y minus 8 equals minus 3x plus 12 with the double minus. Then bringing it to the, bringing the x to the left and the constants to the right. We are going to be left with 3x plus 4y equals 20. Then it says the curve C is used to model the profile of a slide at a water park. Units are in meters, with y being the height of the slide above the water level. Find, according to the model, the greatest height of the slide above the water level. Well, y is 1 minus t cubed. And t ran from, inclusive, yeah, minus 2 to 1 inclusive. And if we want y to be as big as possible, well, we'd like this bit to be negative, because then it would be a double negative. Double negative making it positive, and we'd like to be as big as possible. So if I pick -2 for t, that's going to do that job for me, because then that would give me a -8, and then one double -8 for that. So t is -2, then y would be 1 minus -2 cubed, which is going to leave us with 1 plus 8, or 9 meters. Moving on to question 11. It says figure 5 shows a sketch of part of the curve C with that equation given. The finite region R shaded in figure 5 is bounded by the curve C, the line with equation x equals 1 and the x-axis. And it says, can we find that area? So that's just going to be setting up an integral. So that's going to be the integral of 8x squared e to the -3x dx between the limits of 0 and 1. And then it's a product of two functions, and it's not an f-f thing going on. It's not a reverse chain rule, so I'm going to immediately default to the integration by parts. So let's just write that out. So that's the integral of u dv dx equals uv minus the integral of v du dx. So for us, that's going to be u is, we want to differentiate the 8x squared, so let's call u 8x squared. And then dv dx, we will call that the e to the -3x. So that gives us du dx would be 16x, and the v would be -1/3 of e to the -3x. So that's going to leave our region R to be, well, uv was 8x squared times the -1/3, so that'd be -8/3 x squared, e to the -3x, minus the integral from 0 to 1, and this has got limits on it, sorry, so that's between 0 and 1 also. The integral is from 0 to 1 of v du dx, so that'll be -16/3 x e to the -3x. So that, let's just watch out for that. That's going to be a double minus becoming a plus. In fact, let's just write that out now. We've got -8/3 x squared e to the -3x between 1 and 0. As we plus, let's pull the 16/3 out as well. X e to the -3x dx between 0 and 1. And that's another integration by parts to do. So let's do another integration by parts. This time we're going to differentiate just the x. So let's call u x. Call dv by dx e to the -3x. That gives us du by dx is just 1, and v is -1/3 e to the -3x again. So now our shaded region R is -8/3 x squared e to the -3x, evaluated from 1 to 0, plus 16/3, and then let's put this all in brackets for our next formula. So u times v again, that's -1/3 x e to the -3x, and then we've got minus the integral of this times this, which is going to be a double minus, so let's just actually preempt that double minus and put it as a +1/3 times the integral of e to the -3x, pulling that third out ahead of time. Okay, now let's do that last integral and then bring it all together into one limit. So that's -8/3 x squared e to the -3x. And it'd be -16/9 x e to the -3x. And then the last bit is going to be plus Oh, sorry, actually. It's going to be, because another minus is going to come down, actually. So it's going to be actually minus 16 over 27 e to the minus 3x. And that's evaluated again from 1 to 0. So now plugging in our limits, we do that very carefully. Going to be minus 8/3 of, well, that's x squared, just going to be 1. So just e to the minus 3. Then minus 16 over 9 e to the minus 3. And minus 16 over 27 e to the minus 3. That's our top limit. And then for our second limit, the 0, well, the first two terms have an x on them. So they're just going to come to nothing. We just need to worry about the last guy on the end, which is going to be 16 over 27, or minus 16 over 27, times e to the 0, which is just 1, so just that. So simplifying up, then we have this one term without an e to the minus 3 on it, which is going to be positive 16 over 27, all said and done. And then we need to combine these terms. I'm just going to put them in the calculator. So doing that, we have minus 8 over 3. And we have a minus 16 over 9. And a minus 16 over 27. That gives us minus 136 over 27 e to the minus 3. And let's just check that's in the form they wanted. It just said a and b had to be rational numbers, which they are. So that's my final answer. Okay, moving on to question 12. It says, first, can we express this fraction in partial fractions? So in partial fractions, that's going to be two linear denominator fractions. It would be, a over v plus b over 25 minus v. Rewriting that back as one fraction, that's a times 25 minus v plus b v over v 25 minus v. So now if the denominators are identical, the numerators must be identical. So that is to say 1 must equal a times 25 minus v plus bv for all values of v. So let's pick nice ones. First one I'll pick is v is 25. That would give us 1 equals, this guy would go to 0 because I picked 25. So it would just be plus 25b, meaning that b must be 1 over 25. Then we'll pick 0. So that would give me 1 equals just 25a, because the last term goes to 0, and 25 minus 0 is still 25. So that's 1 over 25. So our partial fractions are 1 over 25v plus 1 over 25 over 25 minus v. Then it says the volume V, microliters of a plant cell, T hours after the plant is watered, is modeled by the differential equation. So it says the plant cell has an initial volume of 20 microliters. So that's saying that V equals 20, 20 equals 0. Find according to the model the time taken in minutes for the volume of the plant to cell to reach 24 microliters. So well, first thing is notice there's a change in units. That's in minutes, so we need to watch out for that because they said t was in hours, so we'll need to convert at some point. If I'm going to work out that time, I need to know the volume at any time, so I'm going to need to solve this differential equation. And let's also just notice there's a similarity here. We can use our partial fractions from before if we are clever. So to do that, let's just move this part to the left with the dv, but leave the 10th alone. And then we can, that'll be the easiest way to use our partial fractions from before. So doing that then, let's first write out the differential equation again. So dv by dt was a 10th v 25 minus v. And we know that when t equals 0, v equals 20. Yep. Then let's move it over, like I said. We'd have the integral of 1 over v times 25 minus v dv equals the integral of 1 over 10 dt. Then splitting those fractions up, writing our partial fractions here instead of this, that's the integral of 1 over 25 v plus 1 over 25 minus v dv equals, I'll just do that integral quickly, that's just a 10th t plus a constant. On the left-hand side, we just got 1 over functions, and it's just 1 over to the power of 1, so it's going to be a natural log. So 1 over 25 natural log of v. Then here we have to watch out because, well, we're going to have a 1 over 25 natural log of 25 minus v. But this minus would actually come out if we were to differentiate it. So we need another minus here to negate it because we want a plus, really. But that gives us that. Then we're going to need to find our plus c, so we can use our initial condition for that. So that would say 1 over 25 natural log of 20 minus 1 over 25 natural log of 25 minus 20 is just 5. So that's 1 over, then the t bit is 0, so that's just 0, and that just leaves us with c. If we simplify that up, we could factorize out the 1 over 25, and then using the subtraction rule for logarithms, just divide the insides of the logarithm. So c would be 1 over 25 natural log 20 divided by 5 is 4. So let's write out our equation again, actually using our plus c that we found. And let's bring it to the other side as well. So if it's plus c there, it would be minus c on the other side. So minus 1 over 25 natural log of 4 equals 1 over 10t. Then if we take out the 1 on 25 from all of this, we can combine all these logarithms. It would be the natural log of v over 4 times 25 minus v. And that's equal to a 10th t. Then let's simplify that again. If we multiply both sides by 10, we'd have 10 over 25. Let's just do that in this line, actually. So get rid of this, put the 10 up here. Then 10 over 25, that is the same as 2/5. Yeah. So t is 2/5 of the natural log of v over 4/25 minus v. Now we're interested in the time when v equals v was equal to what? 24. And we have to watch out, if we remember, for the time as well. But let's first calculate it in hours. So using our calculator, we've got 0.4 for the 2/5 times the natural log of, it would be 24 over 4, where's that bracket there? 4/25 minus 24, which is 0.716 hours. So if I want that in minutes, we just multiply by 60. That's 43 minutes. Okay, then the next part they want us to actually rearrange for v and get it into this form, specifically with the negative exponential in the bottom. So let's start. We have this. We can, if we move the 2/5 back over, we can actually unlog. So let's just copy and paste that over first. Copy. Paste that there. So then we'd have the natural log of v over 425 minus v would equal 5 over 2t. Then we can exponentiate. So v over 425 minus v is equal to e to the 5 over 2t. Now, if we want to start rearranging for v, we need to multiply this fraction up. So that would be v then equals 4 e to the 5 over 2t times 25 minus v. Then expanding that out, we would have v equals 100 e to the 5 over 2t minus 4v e to the 5 over 2t. Let's bring these together so we can factorize them out. So v plus 4v e to the 5 over 2t equals 100 e to the 5 over 2t. Then factorizing the left-hand side, pull the v out. We'd have 1 plus 4 e to the 5 over 2t is 100 e to the 5 over 2t. Then dividing over to get our v on its own, we would have 100 e to the 5 over 2t all over 1 plus 4 e to the 5 over 2t. Then we wanted the negative exponential form with the two constants. So to get rid of these positive exponentials, let's just multiply the top and bottom by e to the minus 5 over 2t. Because using our rules for indices, we know that these guys will combine to give a power of 0. So they'll vanish, as well as I'm actually allowed to do that because this is just multiplying by 1, so it's not changing the value of my fraction at all. That would leave us with 100 over e to the minus 5 over 2t plus 4. Then the last bit, it says the model predicts that there is an upper limit L microliters on the volume of the plant cell. Find the value of L. So if we look at our function here, it's a fraction overall. So if we'd like it to be as large as possible, we want our denominator to be as small as possible. And the smallest we could make it is, well, we need to make this guy, well, we can't actually make him negative. So the best we could do is get him to 0. So that would happen as t tends to infinity. So e to the minus 5 over 2t, a negative exponential, we know would go to 0. That means, not r, sorry, v would tend towards 100 over 0 plus 4, i.e. 25 would be the upper limit. Moving on now to question 13. It says, the world human population P in billions is modeled by the equation P equals AB to the T. So if we know our models that we've been taught to do, that's like a kind of a compound interest type model, where A and B are constant and T is the number of years after 2004. Using the estimated population figures for the years 2004 to 2007, a graph of log P against T, a graph is plotted of log P against T. The points lie approximately on a straight line with, we've been given the gradient and the y-intercept. So the first thing is we can compare those y-intercept and gradient to what we would expect or how it relates to our equation just by logging our equation. So if we start from P equals AB to the T, we log both sides. So log p, or log base 10 of p, same thing, is log base 10 of ab to the t, just logging both sides. Then we can split that log up using the addition rule for logarithms. So that would be log base 10 of b to the t plus log base 10 of a. Then we can bring out that power using the power rule for logarithms. So log base 10 of p must equal log base 10 of b times by the t plus log base 10 of a. So now if we compare this to a y equals mx plus c, then we know that, well, our y-axis is log base 10 of p, like they said, and I forgot the plus c. The x-axis must be t, so whatever's multiplying the x-axis must be our gradient. That's the m. So that is to say, log base 10 of b must equal our gradient of 0.054. Sorry, 0.054. So b is 10 to the power of 0.0054. Plugging that in the calculator. What do we want to round to? 3 decimal places. That would be 1.013 to 3 dp. And then comparing our plus c, we can see that log base 10 of a must be the y-intercept, which is 0.81. So a must be 10 to the power of 0.81, which if we go back and change this, to 3 decimal places would be 6.457 to 3 decimal places again. Okay, then it says in the context of the model. So we need to quote what the units of the model basically interpret the value of a and b. So a, if you forget, you can always check, but you plug in t equals 0, we'd get p equals a times b to the 0, such as p equals a. So in other words, that's the initial population. So we'd say a is the initial population. Let's be specific what initial means. So what was the model for? In 2004, in billions. Yeah, that's what they said. Human population. So of humans, we'll say. And then B is the proportional change what's T measured in per year of humans. Right, proportional change. My bad. Then it says use the model to estimate the world human population in 2030. So we're starting in 2004. So t equals 0 is 2004. So let's just be careful. I need to add on 26, don't I, to get from 2004 to 2030. So if t equals 0 is just 2004, and we add on the 26 to get to the beginning of 2030, does it say that? It just says in 2030, yeah. So that would be when t equals 26. So t equals 26, we get p is our Let's use our precise values for this. So 10 to the 0.81 times 10 to the power of 0.0054, 54, and that's all to the power of 26. So plugging that in the calculator, so 10 to the 0.81 times, open bracket, 10 to the 0.0054, all to the power of 26. That gives us 8.92 billion humans. Comment on the reliability to part C. So our data was from 2004 to 2007. So 2030 would be a long extrapolation outside of our data range. So 2030 is a large extrapolation beyond our data range. Therefore, likely to be unreliable. Moving on to question 14, it says the circle C1 has the following equation. Can we find the coordinates of the center and the radius? So let's put it into the nice form. So first off, if we complete the square for the x terms, that would be x minus 3 squared. We'd get a 9 from that we don't want, so we'll take away a 9. Then the y terms, we'd have y plus 7 squared, which give us a 49 we don't want, so take that away and put the 33 back in. So that was going to leave us with, if I put in the calculator, minus 9 minus 49 plus 33. Leaves with a minus 25, but let's bring that to the other side. So our equation of our circle would be x minus 3 squared, y plus 7 squared equals 25 if I bring that to the other side. So our center is 3 minus 7, and the radius is the square root of 25, which is just 5. Then it says a different circle, C2, has center minus 6 minus 8, and a radius k, where k is a constant. Given that C1 and C2 intersect at 2 distinct points, find the range of values of k, writing your answer in set notation. So we could probably do this with the discriminant, or we could also do it with a nice drawing and just having a think about it. I think let's do the drawing. So if I draw myself some axes here. So our first circle was at 3 minus 7 with a radius of 5. So let's put them here. So it's going to look something like this. That's a rubbish circle. Let's try again. A bit better. Let's just mark on the point. So that was 3 minus 7. And then we've got another circle now at minus 6 minus 8. So actually, I wanted my axes over to the left a bit more, didn't I? Let's just add that on here. So that's going to be well to the left and a little bit lower down. So that's my point there. And if you think about it, there's there's two limits to what can happen here. So one circle could just touch like this. Or the alternative is the upper bound before it Like if I go bigger than that, it's going to intersect twice, but if I go too far, it's going to look something like this, and just sort of touch once, like that. So if we just think about what that is in either case, well, the first one is where we take this distance here. This would be two radiuses of the circle. We'll call that R1 and R2. And then R1 would just have to be like R1, which is like the lower, like the first lower bound, or the lower bound would be the distance between the 2 points. What was the point again? -6, -8. If I just call that the distance for the whole thing, it would be the distance minus R2 would be the lower bound for R1. And then the upper bound would be if it was that lower bound again, plus the full diameter, so going out to the green line. So R2 would just be the same as R1, but actually plus 2 lots of R. Sorry, let's simplify that actually. Let's call it the distance. So from there to there between the 2 points, plus 1 lot of the radius 2 in the circle we had. So let's first work out the distance between the 2 points. So our points were -6, 8. -6, -8, sorry. And our first circle was 3 - 7. So the distance between those 2 points is going to be the square root of, we go along 9, so 9 squared, and we've gone up 1. Plus 1 squared. So let's put that in the calculator quickly. The square root of 9 squared plus 1 root 82. 82. And then the radius of our, I don't know why I wrote R2 earlier, so I could have just written 5, couldn't I? But it is what it is. So R1 is our distance, 82, root 82, but minus one of the radiuses. That's the lower bound. And the upper radius, R2, was the full distance plus that radius. Root 82 plus 5. And then this actually needs to be about k. Well, k was just actually the radius, so that means just k needs to be between root 82 minus 5 and root 82 plus 5. And it actually wanted the answer in set notation, so let's put it in set notation. I can do that just if I say, let's put it in these curly brackets. So k is a real number such that it's between those two values. Moving on to the last question, it says the curve C has equation x plus y cubed, or all cubed, equals 3x squared minus 3y minus 2. Can we find dy by dx in terms of x and y? So that's going to be implicit differentiation. So first off, we'll need the chain rule for this. If we differentiate the inside, x plus y, that just goes to 1 plus dy by dx. Then differentiating the power of 3, that's going to multiply it by 3, reducing the power down to 2. 3x squared is just going to become 6x, and then 3y is just going to become 3 dy by dx, and the 2 would go to 0. Now we just need to rearrange for dy by dx. So first let's bring all the dy by dx's to the left, and I might expand this bracket as well. So we'd have 3 lots of x plus y all squared, plus 3 dy by dx times x plus y all squared. And then plus 3 dy by dx equals 6x. Now let's move anything that doesn't have a dy dx to the other side, as well as factorize the dy by dx out. I think I'll pull the 3 out as well. Actually, we can just cancel off a 3 from everything. Let's do that. So 3, and that'll leave that as a 2. Now if I pull out the dy by dx from everything and move that x plus y squared over, so dy by dx, then open bracket, that would be in x plus y all squared plus 1, and then that would equal 2 minus x plus y all squared. Then we just need to divide. So dy by dx equals 2 minus x plus y all squared over x plus y squared plus 1. Then it says the point P10 lies on C. Show that the normal to C at P has that equation. So first off, we can get the gradient of the tangent just by plugging the point in to our derivative. So that would be 2 minus just 1 squared over 1 squared plus 1. That is going to be 1 over 2, which means the gradient of our normal is going to be minus 2. Then using our formula for a straight line, so y minus the y coordinate, y minus 0 equals our gradient times x minus the x coordinate. Multiplying that out, that does give us minus 2x plus 2, like they asked for. Prove that the normal to C at P does not meet C again. You should use algebra for your proof and make your reasoning clear. Well, if it was going to meet again, we would have to solve simultaneous equations. So basically to show that the equation is not going to have any solutions. So let's solve this simultaneously with our original curve up here. So let's just write that again out here. So we had x plus y cubed equals 3x squared minus 3y minus 2. And then y was minus 2x plus 2. So first, let's substitute the y in and see what that gives us. X minus 2x plus 2 all cubed equals 3x squared minus 3 lots of minus 2x plus 2 minus another 2. Simplifying that down, we would have 2 minus x cubed on the left. And on the right, we would get 3x squared. We would get a plus 6x. And then we'd have a minus 3 times 2, that's minus 6. Minus another 2 is minus 8. And then this is a cubic. But we know one solution, don't we? Because we know one intersection point already. So let's go ahead and expand out. So expanding the left-hand side, let's use binomial expansion, I suppose. So 2 cubed plus 3 choose 1. What 3 choose 1 is just 3. So plus 3 times 2 squared times minus x plus 3 choose 2 is also 3. So plus another 3 times a 2 times a minus x squared. And then the last bit would just be minus x all cubed, which would leave us with actually just minus x cubed, equals 3x squared plus 6x minus 8. So simplifying this line up, well, we've got a minus x cubed, that's the only x cubed term, so we'll move that to the other side to make it positive. Then the x squared terms, we've got a 3x squared here, but we've got a 6x squared here, so subtracting that to the other side, that'll leave us with minus 3x squared. Then our x term, we've got 6x here, but we've got a minus 12x here. So that's going to be 18x if we add it to the other side. And then we've got minus 8 and a positive 8 here, so taking the 8 over, we're going to have a minus 16 equal to 0. And then we remember one solution of this must be the point we started with, which is 1, 0, because that was the point on the curve for the normal. So that means there must be a factor of x minus 1. So let's long divide to simplify our problem down some more. So x minus 1 going into all this. What does that leave us with? X cubed divided by x is just x squared. X squared timesing through on the x minus 1, we get the x cubed back, and then minus x squared. Then minus 3x squared, double minus an x squared. That's minus 2x squared, plus an 18x, bringing that down. Dividing minus 2x squared by x gives us minus 2x. And then multiplying through again, we get minus 2x squared. Minus 1 times minus 2 is plus 2x. Subtracting off, we're going to get 16x, and then bring down the minus 16. Let's check it's actually going to give us remainder 0. 16x divided by 16 divided by x, sorry, is plus 16. So we get 16x minus 16, which does indeed give us a remainder of 0. So now we know this equation is actually x minus 1 times x squared minus 2x plus 16. And if this is if the only solution is this guy, that x equals 1, that means this guy has no solutions, which is just a quadratic. So we can check that by just using the discriminant. So b squared minus 4ac, that's equal to minus 2 squared minus 4 times 1 times 16. Plugging that in to the calculator. Where's my calculator gone? There it is. It would be minus 2 squared is 4, then minus 4 times just the 16 is minus 60, which is less than 0. So therefore, no more solutions. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.